Ever found yourself wondering why a ball on a string doesn't just fly off when you whirl it around? This curious phenomenon is the result of two opposing forces at play, centripetal and centrifugal forces. Dive into the world of centripetal force first. It's the real MVP of the game, the actual force that keeps an object moving along a curved path. This force always points towards the center of the circular path, acting at a right angle to the object's velocity. Consider Earth orbiting the Sun, a car moving along a curved road, or that ball you're whirling around on a string. In each of these scenarios, gravity, friction, or tension act as the centripetal force, pulling the object towards the center of its path. Now take a step into the realm of the centrifugal force. Unlike its counterpart, the centrifugal force isn't an actual force. It's an inertial force, an apparent force that only seems to exist when you're observing from a non-inertial or accelerating reference frame. Imagine water swirling in a spinning bucket or astronauts making sharp turns in a spaceship. In these instances, the water or the astronauts seem to be pushed outwards, but it's just their inertia resisting a change in direction. At a glance, here are the key differences between the two. Centripetal force is a real force that acts towards the center of an object's curved path. It's observed in an inertial reference frame with gravity, tension, and friction as common examples. On the other hand, centrifugal force is an inertial force that appears to act away from the center. It's observed in a non-inertial frame, with spinning water and astronauts making turns as typical examples. To sum it all up, centripetal force is critical for an object to follow a curved path. Without it, the object would simply continue in a straight line. Centrifugal force, on the other hand, is a consequence of being in a non-inertial reference frame. It's not a force in the same sense as centripetal force. So, the next time you whirl that ball on a string, remember the delicate balance of forces that keep it in check. If you have any questions or need further clarification, feel free to ask.